In this video, we're going to solve for the stress of member YR, whose area is equivalent to 5,250 millimeters squared. I hope to understand. So this is the previous thrust that we have. We have the thrust that we were able to solve earlier, and we want to solve for the stress of member YR. The problem is, how do we solve for the force in member YR? Remember that stress is force over area. So we're going to cut this section. This is section B. So if you're going to cut that section and isolate this left side of your section, you will be able to come up with this particular section like this. Okay? So this will be the one, and you have the truss which goes like this. So this is actually your section BB, which is here. It is your section BB, and we are going to isolate the left side. What you see on the left side is you have this 10, you have this one, you have 10, you have another 10, and you have another 10. So all of these are 10. And previously, you were able to solve for the reaction at the hinge, point A, as 37.5, that is 37.5, and this is acting to your right as 10 kilonewtons. You would notice that if you're going to pass this section, all these three members are cut, and to do it is we're going to take the summation of moments at point Z. This is your point Z, this is our X, this is our Y, and this is supposed to be your member YR. This is your member YR, which is this member. Okay? Now, this member YR is actually this one. It is this force, member YR. Actually, it has a vertical component and a horizontal component. And the vertical component is this one. We have here that vertical component, which is this, and a horizontal component, which is that. And that vertical, this horizontal is your member YR, and this horizontal component is equivalent to YR cosine of theta. Now, what is theta? What is this theta? Theta is this particular line whose slope is 4 all over 12. This is 4 all over 12. This is 1, 2, 3. Because everything are, each distances there are 4 meters. So, tangent inverse for theta, you have tangent inverse for theta of 4 all over 12, and inverse tangent of 4 all over 12 is equivalent to 18.43 degrees. Thus, you have here a horizontal component of YR cosine of 18.43 degrees. You also have here a vertical component, but once you're going to take moments at point Z, the vertical component is eliminated. So you would therefore, you are now able to get summation of moments at point Z. If you take summation of moments at Z, clockwise moments are equivalent to counterclockwise moments. What are the clockwise moments? You have here, what are the clockwise moments? You have here the value of this force multiplied by the lever arm. You have YR cosine of 18.43. You multiply it by the lever arm. This lever arm is previously solved equivalent to 20 all over 3. Okay? Other ones are also this one. You have 10. You have 10. You multiply it by that distance, which is 4. It's already given. It's a distance 4. Plus 10. Another 10. You multiply it by that distance, which is 8. Which is equivalent now to 37.5. You have 37.5. You multiply it by 12, because from this, your distance there is 12. Okay? Now take note, you don't have the vertical component of this anymore because it will pass to 0. 10 will also pass to 0, so they're eliminated. Here, if you're going to simplify that equation, you have a result of YR equivalent to 52.18 kilonewtons. So 1 kilonewton is 1,000 newtons. So you have now the stress in your YR, which is equivalent to 52,180 divided by the area, which is 5,250, giving you a result of 9.94 megapascal. So that's the answer. Thank you.